I run this and I check on my console, and there it is. So how do I use this to comment on this? So if you look at it, the last column is, so most people are right-handed, or most people write with what? Their right hand. Okay, I can also divide by the total and talk about it in percentage if I want. Okay, so that's how you look at this. And then for those who write with their right hand, majority of them fold their arms this way. And of course, in the data, most of them fold their arms with all the right hand on top. Is that okay? So we are not going to mention every number in there, the peculiar ones, and then we can say that if you look at those who write with their left hand, those are in the minority, and also those with neither. How is it? It's L on R and then neither. Maybe that is 3, right? Oh. Okay, let's go here. We can get it. Fold, right? We have R on L. Oh, neither, yeah. So there's nothing attached to neither. So we have only one person who is left-handed, and also when the person folds the arms, neither hand is on top. In other words, like this. Is that? Yes, so we are looking at it this way, that way, and maybe that way. This one, there's none of the hand is on top. No, they fold, but neither is on top. So if I do this, which hand is on top? None. Yeah. So, yeah. Whatever you do it, if it is this or clap. Okay, there's clapping. Okay, I'm using the clapping one. There's clap as well. Sorry. So if you fold like this, right? So this is on top. Most people do this. And then this. Well, maybe like that. But you say you fold your arms and none is on top. Okay, I can, well, maybe like this. I'm also folding my hand. So neither is on top. Yeah, so that's it. So, yeah, so that's what the data is telling us. So you look at those in the majority, those in the minority. Then, of course, you can talk about people with those who fold their arms with the right hand on the left, okay, are in the majority. And if you look at them, they are 237, more than 50%. Is it more than 120? Yes. So we can say that more than 50% fold their arms with all the right on top. So you can look at it. All of us, we can ask you to talk about this, and you realize that we can all look at it from different angles and get all different write-ups on the same data. But the key thing is that do not repeat what the data, the table is telling us. What you need to tell us are the interpretation you are putting on it. More of the people are doing this. This shows that, maybe that, and so forth, and that's what you. And when you have this, remember we talked about sum computation. So sum will give me, if I sum what is in the table, it should give me were they 236? 237. So it means we may have a missing data. So I can check this and see, yes, there are some NAs in there. Yeah. So if there are NAs, it won't count it, and that's what we see. So in those one of them had missing what? Data. Okay. What I'm saying is that if I then do this, what do you think I'll get? This one. If I run this, what is going to happen? I am dividing each value in the table by what? The sum. So what do I get? It's a proportional probability. Is that okay? So I can also, this is it, and I can multiply this by 100, okay, and I'll get something like that. So these are percentages, right? And I can round it, so you can round the value, and it asks how many digits, maybe 2. So in this case, I'm going to get 2 decimal places. Okay. So right on top, it's more than 50%, just about 51 or so. So these people, they are in the majority. The last one, those who fold their arms with what? They write on top. You can do the same exercise for clapping. Okay, and that's what I was doing. So people clap like this in church, and like that, and then like that. Okay, so if we want to study, those who clap like this, they have neither hand on top. People will be clapping like this, right hand on top, and those who clap like this, left hand on top. So we can study relationships like that. Okay, so now once you have your contingency table, this is one way of, and you are doing this in probability as well. So if you divide, you get it. And it's easier to communicate probability in what? In percentages. Okay, so you can multiply by 100 and talk about it. All right. Now, so we go to the B part. Is everybody okay with the table?
Well, this time we'll
So that's the table. Here, let me make a comment. So create a crosstab. So it's either crosstab or contingency table. And then here, what are we doing? Over here, what did we do? Calculate. So here we calculate the percentages, right? And we also round it to what? 2 decimal places. So that's what was done, and we got our results like that. Okay, so now let's look at the B. The B part, what are we supposed to do? We have to illustrate this with what? A bar chart and comment on the results. Okay, so how do we create a bar chart? It's bar plot. So we run this. Okay, so bar plot is like this. There are several arguments. As I said, you can go through it to know what each of them is, and so forth. So first of all, I can just copy, and please look at the way I do this. If you are not, okay, so mostly because I've been doing this, I have it, often I can just write it. But the key thing is that just, if you are not conversant, just question mark and copy, then you fill in. In that case, you don't make mistakes. So that's it. So you have it like this. If you need an argument, you go and copy and paste. Or when you start writing, it will show up. But you only write if you know what you have to get. So if you don't know, just look at this. So if I scroll down, there is height. So what is it telling me? height is either a vector or a matrix of values. So the table we created is a matrix. We cannot pass a matrix to, let's say, a pie chart and so forth. So when we get to pie chart and and that's why we started with data structures. Okay, every function will take a particular data structure. If it is a matrix and you give it a data frame, if it's a matrix, then it means that it must contain what? One data type. So if you put in a data frame with other data types, it won't be able to take it, so to speak. So it is important that we know what data types are. With space and so forth, legend.text. Beside, we will do this if you want it to be. So once we will use the argument beside, but let's first plot it and see. So height will be the table that we've created. So we do that and it's like this. Doesn't look nice, no colored, and so forth. Okay. So what do we do? Well, I can go back. First of all, get the margins set so that it's I have enough space around it to display it like this. So now it looks better. Then I need to color. So you have to, the bars contain how many colors? 2. If I have done it the other way, it will contain, so some of you did it the other way. You have only 2 bars, but the divisions will be what? 3. So it depends on how you want to present it. So if there's 2 colors, I can write it. I can, let's say, choose red and maybe blue. Remember, I can also use numbers, isn't it? Yeah. But in this case, it's even better if you use numbers. Okay, but let me see whether my legend will come. And remember, yesterday we talked about legend, right? And the legend will be what? We use the row names, isn't it? Will it be row names? Yes, left or right. So row names. Okay, so whichever one you use, either row names or so row names of the table that I'm writing. Ooh, something is wrong. Okay, I get it. Okay, so sometimes you get to experience this. Okay, so what is happening here is that if you look at it, there is a small apostrophe sign. Once you open something like that, it needs its counterpart to end it. So if it is not getting it, you see plus, I can do everything over here again. I'm not going to get anything. It will just continue like that. Okay, so this one I've even exited the loop. So it means that I need to go in there and delete it. Otherwise, whatever I'm doing will not work. Okay, so this is it. So that's our box pie chart. This is stack. Okay, so each of them is stacked. When we finish, we are going. So this means beside is false by default. So we can also do it beside is true, and then it will plot them this one, and then this one assigned to, but in group. So this one I need to label this. What is this? This is a fold, isn't it? Yeah. So that is not labeled. We need to label it. So I go in again, comma. Then my S, that is S label. S label will be what? Fold. What about Y? What about the Y label? What will the Y label be? Are you sure? Number of students, yes. Number of students. So there we go. Okay. So that's it with the way we, yes. To not to cover. We need to do it separately. Yeah, so if you want to do it separately, you have to finish. You get your bar plot, then you use legend. So the legend is actually a function. Legend like this. So adding legend. So you come to use it. So here you can specify X and Y where you want to place it. And we can also place it on the left, top right, bottom left, and so forth. So I can show that. So let's say I want to plot again, color legends. So I'll take my legends off. Okay. And then I run this. Okay. Then I want to, so this one, okay, I'm also part of it because I put the margins are so small. Or if I want, I can also give it. Okay, so this one you see it a bit. I can also stretch the Y limit so that the bars come down a bit and then I have more space to put my legend. But if the legend is on the bar and it doesn't obstruct it, it's fine. Yeah, it doesn't obstruct it, it's fine. But this, I can then put my legend there. So legend, I'll say this is, I can put it on the top left. So I'll write top left. Then legend is equal to, I think, row names. Okay, so I need to take this one off. What else do I have to? Then I think you have to bring color. Will be equal to the color I did over here. It should match to this. What else? Let me see. I think I need fill. No, rather fill. Is this? There we go. So if I drew the legend outside, I'm at liberty to choose where to put it. I can specify X and Y, but in this case we can't be because this is not a, what do we call it? So for Y I can specify maybe 80, but at the X counterpart Y I won't be able to. Sorry, X counterpart X. If it is numeric, then I can specify it at this point. So at this level, you can just do either top left, bottom right, and so forth. So for the legend, you can create it within, or so let me say adding legend. So this place is adding legend. Adding legends. Or maybe outside of the plot. And we use the same concept whether it's a histogram or the other plot. You can create a legend outside it. So first of all, get the graph without a legend, and then you state what the legend is. Our legend here is all the row names. Okay, and then what are you filling it with? It must correspond to the color, sometimes line types we have used. Remember, we can get a graph where some of the lines are dotted. I'll show you some later on that you can do all of that in there. and then I place it. So here, what I'm saying is that put the legend on the top left hand, because that's where I had space, right? And then, what is the legend? The row names, and it must fill it with the color, because it's the color that is differentiating the bars. Okay. Please, any question? Are we done? Okay. So if we are done, we want to also see the side-by-side bar graph. We can get something like this. So this is not a histogram. It's rather a bar chart, but with different order. So these are the same group, the same group, the same group, but divided into. So how do you get that? So what we've done here is a stack, what we call the stack bar graph. It means that it's components. If it's stacked, it means we've stacked it on top. Okay. Then we can have what we call the side-by-side bar graph. They are all side-by-side bar graph. So how do we get that? Well, bar. You get that by using the argument beside. So go to the help, look at help of bar plot, look at the argument beside. We can even let it be horizontal. So horizontal by default is false. If we take it to true, if false, the bars are drawn vertically. So you see all the bars. If we want it to be like that, what do? With horizontal is all true, and then it will go like that. So for example, but here, if I do that, let's see if you can help out. So side by side is going to be like this. So I'll call the argument beside, and I will start writing, and then I wait. It comes, I select, so I don't do it, and then I write true. Okay, so this is it. So you see how this, so R on L, this one, and so forth. So neither, remember it was 1, so it's draft. You can't really see the line, the frequency. So that's the function of the beside. Right? Okay. And then, let's assume I want to do horizontal. So I want it to be horizontal. Please look at it and tell me what will be wrong or what is wrong. Horizontal is true. So true to T, capital T is also true. So you are not supposed to be using true to name your object. Okay, I can use C tab 1 and so because it's not a function in R. So T is an inbuilt function. Now, what is wrong here? They are good. You see, I named it. At first, S lab was this. So you cannot have number of students and it is left on right. Is everybody okay with this? Yeah, so if I were to do this horizontally, then I need to also change the graph. So S lab become what? Y lab, and then Y lab become what? S lab. So once I do this, it will then be, oh, my spelling of students was wrong. Student. So I rewrite it, and it's like this. Okay, so if you want it to be horizontal, horizontal is all true. So in R, you have absolute control by whatever you want to display, and especially on graphs. Okay. And of course, you can add your legend. So this one, I can call the legend that I did, and I'm going to say put it on the bottom right, because I have space there. Okay, so instead of top left, I'll say bottom right. So I understand what is bottom right, bottom left, and there it is. So whatever you want to do, you have absolute control. Okay, Let's hurry up and then now. So that's for bar charts. We now move into pie charts. Okay, so let's hurry up. Okay. Shall we move on? Please, can we move on? Oh, someone, if you are facing difficulties, let us know. So, otherwise, we move on. Okay. So, pie. Please. Sorry. So pie chart is like that. Remember, we talked about it yesterday over here, right? So we're going to create the same table. We've already created a table. As for pie chart, we cannot be using it for the complicated case. It has to just be one variable. You cannot be using two variables. So if you have a contingency table, then the bar chart is the best way to do it. So this one will take just one variable. Okay, so let's look at so yesterday I made comment. You have, let's say, right-hand hand of students, and there are only two groups. Okay, you can use a sentence to tell the reader the distribution. Okay, so in that case, you do not really need a graph to show male and female. You can just say that in the population, females are in the majority. They are what? 60%. And the males are 40. That's it. Okay, so usually graphs, when you have complicated stuff to communicate, then you use it. So if we have just two like this, so to do pie charts, we use pi. All right, so let's say I want pi of the right hand. So I can call, no, you need a table before. So, but you can put all of them. What's the right hand, right? Okay. So F tab W is the right hand, or let's say WH. You don't need to name it like I do, but it's up to you. You can use any name. So survey, then W hand. So I do this, and then I check. Two 1/8 right with their right hand and so forth. So if I want, I can just get a percentage, right? I I can also get a percentage just like we did. So sum of what? F tab, if you do this. So you see, more than 90%, or approximately 92% are what? Are right-handed. That's it. We move on. Is that okay? So this one, it doesn't really need a graph, but for the argument's sake, we are going to plot a pie chart. There it is, left, right. Okay, so if you want a chart, you can use it and talk about it. Okay, but these charts are not nice. You see, it sits somewhere in between them and so forth. So the pie, if we go in, we can check the arguments. So there are so many stuff, clockwise, edges, radius. So the radius is small. If I want it to be large, I can copy the radius and come put it over here and give it, let's say, 1.8 and see the way it looks like. You see now it overshoots my plotting area. Okay, so I need to reduce it maybe to 1.2. There. So maybe 1. There. But it still doesn't look nice. So I want you to install the package called, please be with us, otherwise you will get lost. There's a package called Plotrace. So let's install it quickly. And if you install Plotrace, there is a Pi 3D, which is display what? A 3D pie chart. So we can use a 3D pie chart rather than the one we have over there. So forth. So let's look at it and see. So display a 3D pie chart. So Pi 3D, edges, radius is 1, height is this, theta is equal to pi, color is now labels, label position, label that, label dot sex, sector dot order, explode, shade, map, pt, so a whole lot. And if you go down, it will show you all the what the radius, pi, the start, the angle at which to start, border, color, and so forth. Okay, so let's install it quickly. When you are done, please let me know. Plotrace. Plotrace. Yes. Are you done? Shall we move on? Yes. Yes. Okay, what's it? You cannot. What is the R version you are using? Check the console. No, download the new one because we are in 4.51. So just go to R, download R, and download the new one. That it should be displayed. Have you been able to install? Check if you've been able to install the package. You need to install the package. How do you install it? Package is installed and you can package for it and you work on it. So if you have been able to install it, load it into your will take it and do question mark I3D. To show you the way I got the help. So let's hurry up. We must get this thing done quickly. Okay, so library, plot trace, or and then Pi3D. You should get this. So we are going to look at how we can use it to generate what? Pie chart that are in 3D format. So anytime you need to use a function, what you need to do is to what? Get the help files for it, and then you see. So x, what is x? X is a numeric vector for which each value will be what? A sector. So it means that this one you cannot go and pass a matrix or a data frame to it. It must be what? A vector. Okay. Then the edges, the number of lines forming. I mean, there are so many of them, you may not need all of them. So we will do it, and the most important ones we will talk about it. So first of all, we just need a Pi3D. So I copy it over here. X is equal to what? Is my table, right? 2. But we'll use another one soon. So let's just do this. So there it is. It's like this. No label, nothing. Okay? So even though it's nice, it just sits somewhere like a star. We are seeing it in the. We need to expand it. Okay, so how do you expand it? We go back over here. The radius by default is 1. But we need more, so it means that if I increase it, the graph is going to be increased. So let me increase it to 2 and see what it looks like. So it's getting bigger. Okay, so if I want 3, maybe 3 is fine, or 4. There. So this will expand it, and you have, this is far better than the one we use. Okay. Then I can go back. How do I get labels? Because here we won't know which color is which and so forth. We can get a legend, or we can actually write the label on it. So if you look over here, the height 2, you can increase it if you want. So by default it's all 0.1. So it means if I increase it, it's going to, so let me give it 0.5 and then we'll see how it looks like. Is that okay? Good. Okay. So this is far better than the other one. So you can play around with any, we can't teach you everything. It's up to you to be exploring. Okay. Now, what else can we color? As we have color already, but you can change the color. Okay. Then label is null, but we want to label it. So how do I label it? I need to provide it with what? What are the names? This will be names of what? What I have over here, which is what? Left, right. So how do I get that? I can use C left, right, or I can call the names. Remember the other one, we're using row names, right? Yeah, so this one is a vector. So for vector, we only have what? Names. So if I, let's say, call this, I'm going to get left and right. So it means if I do it like this, left, right. Okay. You can even put the position of it. It is telling you label position. Now, so if I come here to show me how label position is, optional, positions for the label, see examples. So if you say see example, I can go down there and check some of the examples and see how the labeling is done. So labels equal to pi labels. So pi labels We cannot survive. We want to survive. So we hate pi. Okay, so it's pi value labels. So it's not really important. Okay. So that's it with the pi. Another important thing you may also do is sometimes you want to explode it so that it's distinct, right? Okay, so another variable of interest is explode. So by default, and then let me talk about the, there's also the label sex. This one. So you see, if I want to reduce the writing over left, right, left, if it's too big, I can reduce it. Or if it is too small, I can also increase it. So you use this label sex. Whenever you see sex, it's like the character expansion. Okay, so label means label character expansion. So if I reduce it to 1.0, it's going to decrease in size. Okay, so that's by default 1. And if I do it 2, it's going to be even what? More bigger. So it depends on what you want. Usually 1 is fine because it mimics the characters we want to use. Okay, what else can we do? I talk about explode. So by default, explode, if you come here, you see what explode is. So you look at it, explode is or the amount to explode the pie in user units. Okay, so by default it is 0. So it means if you are increasing it, it will go above it. You can even shade. So there's so much you can do in this. Yes. Yes, please go ahead.
So the right and left, what's the interesting? So I'm thinking that our interest is to know what the red stands for and what the blue also stands for.
So the left is the red. The left is the red. But is there, look at it. Left is the small one and so forth. Yeah. So let me reduce this so that I can see. So that's explode. You see, it will take the habit off. Okay, the more you increase it, the more it will get out of it. 8. Okay, so you can take it off completely. There. Okay, so as you increase the if you don't change when I did 4, it was almost full. If it is full to the edges and I'm now exploding it, it will go beyond it. So for me to make sure that they are within, you see I reduce the radius to 2 so that it will be smaller and then I can take them off. Yeah. So I mean, these kind of things, you are at liberty to do what you want to. Yeah, you need to program a bit. If we want the percentage, it means that we have to create our own label with the percentage. We can do it. Yes.
Does the order of the argument matter?
Order of the argument.
If you bring it to look before maybe height or...
Oh no, it doesn't matter. Yeah. I actually can even act on the position. But that's a dangerous way of programming. Because we can swap things around, but the order doesn't matter at all, provided it is named. Yeah. Yeah, hello? You, okay, all right. Okay, please, any question? Any question? We are good. Okay. Yes. Do we? Oh, as for pie chart, you don't. Oh, you can label it, but you see, you are going to do figure this. So once the sectors have been labeled, that's it. Yeah. What Samuela asks is what you can do next, which is give, let's say, a percentage of it if you want to. But that, if we want to do it, I want us to move on, so I don't want to be adding. But I can just record a video on it for you to do so. What you need to do is that we have to create a new label. Let's say we call it label. And then that label should be able to be of this form. Like, see, we have, let's say, left, right? Left. And then left is, it was, I think, around 8%. Right? I can do so. But that means I need to calculate and know that. And then the next one will be what? Right. And then that is what? 92%. So I can do so, and then instead of the names, I can attach this to it. But you can also write it in such a way that I will just paste it and so forth. So this one, I can easily do that, but that's a crude way of doing it. We can also use the paste function. Then whenever I change the data, it will still take it automatically. So this one, if you want to use that, instead of names this, I'll get a percentage. So how do I get a percentage? Let's say this will be C. We know the percentage already. What was it? That is 7.6% and what? 92.3. Okay. So if I want to do that, I can do it and say left. And then, what do I say? So 7 point. Is that okay? And then the next one will be what? Right. But you see, if you have 10, you can't be doing this. That's why I'm saying it's a crude way. I can do it by using the paste function. So I calculate I calculate the percentages like what I have done now, and then I need to call the names and paste it so that it becomes a vector on its own. But I don't want to be going through all this. I'll just record a video for you to do so. 92.4, right? Percent. Okay. So if I have this, I can redo this and paste it there. So my pi so I'll copy the same function I did. So the labels, I think it has to be the other way around. Okay, let me do it. If it doesn't work, I change it. Because this one too, you have to make sure that it follows the way the graphs has been done. Yeah, that's it. So if this is what you want, there we have it. Okay, and point 8. Samuel, was that what you wanted? Good, yeah. So left 7.6 and so forth. Yes. Yes, it's inside. Yes, it's just so I know the percentages. I create my labels and name it per label, and then I pass it through my pi function. Yes. 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 So you have to go through again and change. That's what I was saying, that there's a crude way of doing it. So ideally, I have to create the percentage, right? So percent, let's say percent is assigned, what is it? How did I do that? Is this one. Then I multiply by 100 and round it. So I multiply this by 100. And I want to round it to, let's say, what did we use? 1 decimal place. So 1, like this. So this is it. Left, right. Okay. Now, once that is done, it means that I can also call, I need to write the name, and then I assign this percent to it. Is that okay? Just like I did. Okay, now how do I do that? Well, I need to, okay, I have the row names. Okay, so that's fine. So I'll use what we call paste. Paste. Okay. So paste. You paste something, what is separating it, and so forth. Okay, so I call paste. Not paste 0, like paste like this. Okay. Then I can call the row names, right? Oh, it's not row names, but rather names, right? Names of FTW. What? So this, if I, this left, right, is that okay? Now, but each of these, I want to separate it with what? What do I want to separate? Maybe, what will separate them? I need space and what again? Maybe comma, right? So, or no, let me just put this in quotation mark. This one. So I write the name, I put that, and then the next one, I put the percentage. Okay. And then after the percentage, I need to close. Yes, I need to close it with a bracket. And then after that, okay, so you have days, label, percentages, and then I need a percentage sign before this. Right, and then separator, what should separate them? Separator should be less, okay, maybe space, so just space in between them. So let me see how this looks like. Okay, so you see what I was writing now I can have it like this. So if they were 5 or whatever, they will be written. I don't need to do this often. This is the same as what I did over here. But as I said, that was a crude way of doing it. Okay, so it is simple. The paste function is that I take first the names, then comma, so that will write left. Then after the left, I need space. So you see here, I gave space. If I don't, if I do it like this, you realize that the bracket will be attached to the I can just run it. If you want it this way, that's fine. If you want to give space before the percentage, you need to. So that's it with it. Then I call the number, which is the percent. And then I close it. I will not be able to write percentage. So I need to provide it and put it in quotation mark, just like I did earlier. And then how do you want to separate them? I said none. So there's no, if I want to separate them, the two of them by, let's say, this, I can also do so. Okay, then it will separate everything you have done with, but that's not a good way of doing it. So that's it. You just separate them with an empty word like this. Okay. So now that I have this will be my labels. So let me call it my label. So if I call my function, Pi3D, the labels will be what? Will be my label, and that's it. So I can call this again. I call this again, and then instead of names this, I put what? My label. And I run this. My label not found. It means I did not run it. There we go. Okay, so let me say explode. Let me give it 0.51. Okay, so there it is. So we can actually do this. Yeah, we can do it. I didn't want to waste time, but I think the main principle is here. If you get this, that's it. So that's using paste. So we can paste, cut allows us to just display the content on the screen. Yeah, so cut, paste, they are for strings and so forth. Grep as well, and string and so forth. So we can use that to program to do all those stuff. What are you writing there? Which one? Is it this? The label. Okay. Oh, I'll send this as well to your page once we are done. So that's the, okay, so let me, here was adding percentages. Adding percentages to pie chart. Oh, it's sectors, right? To sectors rather than the pie chart. To sectors. Please, any question? Can we move on or we should take a break? Okay, let's take a break. When we come back, I'm moving on to data ranking. If you don't want to take a break, please construct a pie chart for the CAS 93 data. Let's look at the pie chart for the type of card. Is that okay? And let's label it. That's for those who are not going on. No, the type. Yeah. No, the model they are so many. So let's look at the type. I think there are 6 of them. 40. So let's do that quickly. So first of all, you need a table, right? And this one, if you, the names, if you want this, you keep this. So all you have to do is to repeat the percentages for the next one. And that will be done. So first of all, we want to create a pie chart for car types in the CAS 93 data. The CAS 93 data. So what do you do? First of all, you need frequency, let's say type. So I'll look at table. I start typing CAS 93. I select, we say type, and then I run this. So when I check this, I have 6, 16, 20, 14, and so forth. Okay. So that's the type. Okay. Now, because we want percentage, I'll have to calculate the percentage, right? Is everybody okay? So, pairs, okay, will then be assigned what? The frec. Remember, we want to round it. Let's finish, then we round it. Oh, not my label. So this, what's happening? Divided by what? The sum of this. Now, if you run this alone, it should give you this. But I want to do it to what? To 1 decimal place, right? Okay, so if it's 1 decimal place, what do I do? You round it. Okay. So let's round. And then to what? To only 1 decimal place, so we just write 1 after. But ideally, it should be digit equal to 1. Okay. So when we do this, and you display, this is it, 0.2, 0.2. I have not multiplied by 100. So I need to multiply it by what? 100. And then now we'll see 17 through and so forth. Is everybody okay with that? Okay, good. Okay, so that's my percentage. Then I can go over here and copy what I did over here. So my label 2. So you want to create the labels before you even start getting the pie chart, isn't it? Yeah. So let's say so I name it my type or type lab. So this one, it will be names of this. It will be names of what? Freg type, isn't it? Because that's the new one. Okay. And then by this space, I made it. You see, you have to. The other one was small letter. R is case sensitive. Okay, so I do this. If I check my, so you see compact 72%, this, that, so you can always have it like that. Is it not working? So it means if people don't want to go. Okay, so this are we done. So recording the percentage, our label is done already. What is left is for us to be able to. Yes. I went to copy what we did. I only changed what is inside. Other than that, you will make it. So if you are lacking behind this, let's start with this. Otherwise, you will always be go from there. So we copy this. Click forward and then you can move on. Okay, so that's the type. And then next, what do? We can now do a box plot, and the label will be this, isn't it? Yeah, that's it. So let me put in comments because I will send it to you. I'm Cast 93. So here, I create a frequency table. Creates a frequency table. The next one, we create what? Percentage frequency table, or what we call relative frequency table. Then the next one, creates a label with what? Percentages. So this creates a label with what? Percentages attached. So basically that's what we've done. The next thing is that we can now plot the bar chart. Is everybody okay with this? Okay. Oh, pie chart, yeah. Sorry. Create a pie chart. How do we do that? How do we create a pie chart? Can we move on? Can we move on? I'm waiting. Please, can we move on? What is the problem? If you are facing problems, please let us know. You have to always be careful with the commas and brackets and so forth. So, table, create your label. Oh, label. You create your label, then once the label has been created, the next thing we have to do is to create the bar chart. So the bar chart, pie chart, what do? We'll call pie. It can be pie or pie 3D, but we've realized that pie 3D is better. So we call pie 3D. We give it a label, and the label is what? It's a new label we've created. Right? And that's it. So so Pi 3D. We can even go and copy. So if you have done this, just go up there and copy this. Don't type again. You can copy and paste here. Then you are going to change what is here. So for example, you can even use a percentage to also plot. That's also the data. It's also a vector. So you can also use that. But this one is all. Label will change. And then I can do this. It's not looking nice. It's not looking nice at all. So this one, I can reduce it to some value, like 3. Explode, I'll let it be small, and then the radius should I increase it or? Okay, let me run this and see. Okay, you see it, but it's also very small. So the label 6 is a bit too small. Let me do it 6.3 and see. Okay, so a bit. Maybe I can increase the radius to 3 to see how it looks like. Yeah. But some of them will overlap and so forth. Okay. But essentially you can see what is going in there. So the mid-size are in the majority. Then the small size follows. Then the compact and so forth. Okay, so let me go around and see. If you have issues, please let us know so that we can all collaborate. As I said, what we have done, I've just copied and finished. And so go back. All these are telling you that they are copied. So you break this one down so that you have Please, are you done? So let's move on now. We are moving on. We'll come back to graphical displays later on, see how we can have this done. So, yeah. You are now going for your break. Okay. All right. So now we are going to talk about what we data wranglings. So what are we going to do here? Well, remember we want to be able to talk about big data, how to make meaning out of large data set that is being churned at a high velocity, it's unstructured and so forth. So we should be able to get data and be able to do either select or take some out and so forth. Add on, because the data is always coming in and some are obsolete, you have to take them out and so forth. We have to know how to do all of it. Now, if I have a data frame and I want to take the first column out, what do I have to do? select. Just run the file. I think you are typing to yourself. So read now. So you have to select. Otherwise you will make mistakes or take your time. Then you have to select. That's how let's equal to 2. Okay, so I have a data set. Let's say the cars 93, but the okay, so let's see. So I want you to take out the first column. Why are you going to do that? We have a data set. We realize that this variable, we don't need it again. And we want to take it out from the first column. What do we have to do? Good. Okay, so that's how we do it. What if we want to add on to it? So that's the sort of thing we are going to do now. So let's say I have a data set. There's a data set called, let's say, anorexia. Okay, so it's made up of treatment, pre-weight, and post-weight. I want to plot pre-weight and post-weight and look at the differences. Okay, and if I did not use this, so if I say box plot of this, okay, even though the treatment is not numeric, box plot still manages to get something for it. But it doesn't make sense to be plotting CBT, treatment. Treatment are in categories. How do you plot them, a box plot for it? Doesn't make sense. Okay, so we want to omit. Okay, so in this case, the first one we talk about is omitting, let's say it can be rows, which is observations, and or columns. But it can also refer to a vector and omit. Or deleting this, I think that would be deleting rows and columns. Okay, so anorexia, the head of anorexia is this. That displays pre-weight and so forth. If I want to delete, okay, what do we have to use? So let's say I want to delete the treatment, treat. What do I have to do? I call anorexia. Because it's column, I'm going to put this minus what? 1. Because that's the position. Okay. Then I do this. So you look at it, you realize there's no treatment now. It's only what? Pre and post weight. Is everybody okay with this? Is everybody okay? So if I name this my anorexia, I can now do the head of my anorexia, and you realize that there will be no what? There's no what? Treatment in there. Please, is everybody okay with this? Good, okay. Now, So you can do so with what? Negating the position. What if I want to take out the third person from the list? Or the third and the first person on the list and the third person, I want to take them out. Then it means I have to bring that as a vector before the column. So delete first and third person. If we, data I think the best thing will be observations. So how do I do that? I'll still call anorexia, and then I put this. Then I want -1 and or 3. Is that okay? So I put negative before that, or I can also put on -1 and what? -3. Is everybody okay with that? Is everybody okay? So if I do this, I'll definitely be not getting what? The first and third. So you see it start from 2, 4, and so forth. Please, is everybody okay with this? So we can actually use what? These minus and so forth to what? To delete object or remove. Now one more thing. We will be dealing with big data sets. We haven't started at all. These are preliminary remarks. Okay, so now if we have a big data, then I say delete, let's say the type of cars. And a big data, it may have, let's say, 1,000 variables. You are now going to go through the columns and be checking which number is type. You can't be doing that. Is that okay? So most of the things we'll be doing, you need to be able to program or do that automatically, not through counting or observation. So what do we do? Well, we can search for the position of that particular column. So we will be looking at the function which. It's very important. Which. So if I want to see, let's look at the Cars 93 data. We want to find what is the position of type of cars. Is that okay? Or let's say the minimum price, so to speak. I think type is the first one also. Is type second? What? So I can get a call names of Cars 93. What would this give me? If I run this code, what am I going to get? All the variable names, so to speak. Okay, so we run that. So which function? Okay. Now, so if you look at it, type is number 3, right? So assuming I don't want to be doing this, because as I said, we can get data, a large data set, and we can't be doing this to go through till you find the number. So what I'm going to do is that I'm going to use which. So which of these call names is equal to type? That will give me the position. So we all know that it is 3. So I'm going to use which. So I'm going to say which. Which why is this? Okay. So which? So what the data you have and what the data is odd, or the column names we are looking for is called this. Then I'm checking which of them is equal to, so relational. And this is why I don't use equal to do assignment. Because the double of it is to check whether they are equal. So if you are fond of using this, when assignment statement you are using equal to, the next time it is double, it's going to change whatever you are doing. And sometimes I said if you are doing big data, you will not be having access to the data. You have to be working with maybe a cloud of computers. You will not be there to be checking whatever. So everything you've done is programmed. So if it is equal to and you put equal to twice, you are not actually checking or assigning. You are actually checking whether they are equal. And your result will be completely wrong. So you have to be very careful with whatever you do in programming. Okay, so which one is equal to type? Okay, so let's check anything you want. So let's check type first. It's 3. Do we all agree? It's 3. Okay, so if I want width, or maybe width is somewhere here. Width is also 21. Let's see whether we get the same. And it's 21. And so forth. So you can use which to search for some of these things. Actually, what is inside here, if you run this alone, what do you think will be the outcome? Yes, what will happen? You will get what? We are checking whether they are equal. So the result will be what? True or false? So which actually retains the one that is true? So you see this one, 15 up to 21. And so if I come here and I run it, I'm going to get true for only what? The third position. So which actually retains what? Only the third position. Okay. So it means that for us to be doing this, we can actually just check the index and select it. So if I negate the index, it will take it off. Is that okay? So for example, here, if I say this is index, IND, then I can use the same principle to call cars 93. Okay, and then I put negative of IND. What do you think will happen? IND is what? It's 3. So it will take the type of vehicle off from this data. Okay, so that's how you automatically pick the number without necessarily counting. That's the number of the row number, the column number or the in there. Okay. So that's it with removing or deleting observations, either columns or what? Rows. Next is adding. So adding rows and columns. Columns, adding rows and columns. So this, if you take all the data structures, you can talk about them. Okay? If it is a vector, so I have a vector of, let's say, ages of 5 people, and then I have a new person. What do? I can combine them with the same C. Is everybody okay with that? Yeah. So let's say we have age, and now you are doing probability and so forth. So I can simulate age from a probability distribution. Okay. or I can sample. So here, if I know that our ages are between, let's say, 24 to 45, I can sample people from here. So what I'll say is that I'll write 24 to 45. What this means is that list the numbers, what? 24, 25, 26, and so forth. So if we have column, if I do it the other way, it's going to be the reverse. So for example, if I write 100 is to 1, what it means is I start from 100, 99, 98, and so forth up to what? Up to 100. Okay. So I'm going to sample of size, let's say I want 5 people. Right. So I do this. All of us are going to get different ages because this is random generation. So the first one, we can use this to generate the winning numbers in the national lotteries, right? Don't go and stick someone. I'm showing a disclaimer. Okay. Yeah, but that's really what happens. So my first person, the first person I selected, the person is 35 years. The next person is 38. The next person is 42, 34, 38. Okay. Now, assuming I now have Kwadwo. Kwadwo enters the class, and Kwadwo's age of Kwadwo is what? Is, let's say, 25. How do I add Kwadwo's age to my age already collected? Okay, I'll just use the same C. Do you remember? C. So add Kwadwo's age. So to do that, I'll just call age, then C. I call the other. I'm not going to rewrite everything again. And then I add this age to it, right? It can be that or the number. So now if I do this, I have 6 people, right? Done. Okay. So we can add on to this. If it is a vector, we can also add. Remember, you remember C bind and R bind? Do you remember? Yeah, so that R bind will be used to attach rows. C bind will be used to what? Attach what? Columns. Okay. But, so when we have R, we have a matrix and then we want to attach rows, that's easier. You use R bind. If we want to attach a column, you use C bind. Okay. For a data frame, that's not, if the data frame contains the same data type, we can use the matrix R bind, C bind to do it. But remember, data frame may contain different data types. So we cannot be using C bind and R bind because that's specifically for matrices where it has the same data type. So we can use a function called merge when we have a data frame. Okay, so merge. Let's look at merge. So this one merged 2 data frames. Okay, it merged 2 data frames. And you can merge it by a common column. Okay, if it has one column in common and so forth. Okay. So merge S and Y, and the other stuff you can look at later on. This is not really what I want to draw on. I want us to go to DPLYR. So as I'm doing this, please install this package. By the time we finish, I finish and I go there, you will have it. DPLYR. Yes, this one. So that's the grammar of data manipulation. So what we are doing is just on the base R, but I want you to be able to get this data. DPLYR. So that's the grammar. So we are moving gradually from the base to the grammar. So we do grammar of data manipulation. Then we now do grammar of graphics. Once we are done with that, and then we can now move into our data, our big data framework, to use Spark LYR. So that's the is it? Oh, okay, it's time.
Yes.
Okay. Okay, so let's close. With this. So please, you need to install this. We don't have much time, so when you go home, just if you okay. So I've loaded what we did yesterday. I'll do this as well, but the evening group are ahead because we're able to do this. Okay, so I've loaded it on the YouTube page. Please take your time to go through. It's not difficult. Just take your time, go through it and practice so that next week when we meet on Friday, we can just catch up with it. So the merge, you can go down. If you have done this, when you go home, please install this and go through the video of the other class. I think I'll just record another video on it extensively and post it, so it becomes easier for everyone. But the merge, if you come down here, there are examples here. You can just copy up to the books, okay, up to this, let's say up to here. So you copy paste and just observe what is happening. So let's all copy up to here, and then we run it and we close. So what is happening here, we will know what is happening. So look at this. What is being created here? What is being created here? It's a data frame, because that's what you see. So if we run this, we are going to get what? Authors will be what? A data frame. And if you look at it, it gives you what? The author, the nationality, author, nationality, and whether the person is deceased. Is that okay? All right, so that's the first thing. So one other thing is that you should be able to analyze a code. So you see, we started by learning how to do it ourselves. Now somebody has done it and we need to analyze it. And actually that's what you'll be doing, because you can't be reinventing the wheel. People have done most of the things you will be using. So you just get it, modify it to suit what you want to do. So that's what we are doing. Then here we are using the within function. So if you do this, it takes author and then it is renaming it, and RM is remove. So here whatever is being done, so author n, what is it does is that it has removed. If you look at the first one, the surname is no more. Okay, it has removed the surname, brought the nationality first, and so forth, and has renamed surname as what? Name, and brought it at the end of it. Okay, so you don't see surname again. Then the next one is also books, so it does this. Okay, so if you look at the books, so we got the author, where they come from, and whether they are alive or not. Then the books gives us the books, the name of the author, the title of the book, and whether they are other authors. So you see that they have what? Name in common. And now because of that, I can then merge them into what? M0, which is author and author books. It will not repeat the names because they are common. It will just make it one. So that's what we mean by merge. And now if you look at it, you see it has name, nationality, okay, and then the book title and then other authors. If I do it this way, if I redo it, it may fit all of them in the, you see, on the same row, and then you see it. So that's the merge. So now the name is there, and then assign it to the deceased, the title, and then the author name. So that's what we mean by merging. Okay, but this is still in the base, and once you go home, please go through the data, the grammar of data manipulation. And once you watch it, I'll post another video on YouTube, and then that will end it.